Hello and welcome. My name is Todd Pratt and I'm a solutions engineer with Hyperscience. In today's short webinar, we're going to discuss intelligent document processing and do a quick demonstration of the Hyperscience application. So intelligent document processing, it really refers to any application that can classify and extract specific pieces of information off of different types of documents, either electronically born or scanned images, using artificial intelligence technology to pass that information along to downstream systems or line of business applications. We're often asked how intelligent document processing differs from traditional OCR technology. And OCR has been around for decades. And really, those engines are made to convert images, printed text-based images, into a electronic text-based layer, so that you can then go search inside that layer. The Hyperscience application converts both text and handwriting into usable information, and then using artificial intelligence technologies, classifies the documents and pages that it sees submitted to the application, as well as captures the specific information off of those different types of documents and pages, and then makes that available for the downstream systems. So let's jump right into the application and take a look at that in process. I'm going to upload a document here. And this is really one file, a PDF. We try to make getting information into the Hyperscience application very easy. We can upload things manually like you just saw. We can monitor email addresses or sweep network directories. We have integrations with common automation tools as well as message queues. And you can also interact programmatically through our REST API. As soon as the documents enter the system, they begin processing. And so the first step of that process is to evaluate the different pages inside of that file and classify them into their different document types. Once the software understands the type of document, then it's going to understand which fields it wants off of that specific type, and it's going to start extracting that data, whether it be text or handwritten. So let's take a quick look at the file that was submitted. So you can see lots of different types of information inside of this file. So we have a electronically born PDF that already has a text layer behind it. We have completely handwritten W-9s, and in this case, it's upside down. We have an invoice, another W-9, a pay stub, some blank pages, some junk, and a claim form, and a loan application. Interesting, the loan application has both the combination of text and handwriting mixed together. So the software will evaluate this document page by page. It'll use cleanup techniques and pre-processing that will help to auto-rotate, and has the ability to read despite sort of poor image quality, and even things like scratch out the data that's associated to those forms. So let's go back to the application and see how well it performed. Okay, so let's take a look inside of the submission. Move my face here. So the first thing you'll notice is that the software page by page classified and separated the document into individual documents or layout types. So we have a couple of W-9s here, and we have a couple of versions of that W-9 that the software was able to identify: the claim form, the loan application, and then we have the waybills, the invoices, and the pay stubs. So you'll notice as we go through here a couple of differences for documents that have a known layout, like a W-9. We call those structured documents, and the software can expect where to find the information, and so we can effectively draw a box around where the data should exist, and the software can extract that information. When it comes to things like waybills or invoices or pay stubs, then the software has a little more to do. So it has to predict where the field, the data is going to exist on the form, because from invoice to invoice or pay stub to pay stub, the pieces of information that you might want sort of move around the page. So there's two steps to the process. First, the software has to identify where the field exists, and then it has to transcribe that field or extract the information from where it identified it. So on the right-hand side, you can see that in some cases, the software was able to transcribe a document fully, which means that we achieved 100% automation. And in some cases, it's asking for an operator to perform some manual transcription. One of the unique things about the hyperscience application is our ability to set an output SLA accuracy. So I'm not talking about how well the machine read. I'm talking about when the document comes, or when the data comes outside of the application, how accurate can our clients expect that information to be? Well, humans, as they type, or data entry operators, good data entry operators, are typically between 98, 99% accurate. Most of our customers want at least that or better accuracy coming out and expect it from our application. So we can actually set the output SLA. The software will then determine what fields need to go to a human operator so that we can meet that SLA. That sort of raises its hand and asks a friend for help to make sure that we maintain that SLA and the accuracy that our customers expect from the data as it exits the application. So in order to do that, we have a work queue, and I'm just going to go through that, and then we'll come back and take a look at the actual final product. So hopping over to the work queue, this is where an operator would either be notified, or this is where they would spend their day looking at the documents that enter the system. So we see that we have 2 identification entries to review and 2 transcription entries to review. So let's perform those tasks. Let's start with identification. And this will be around the semi-structured documents. So quite simply, the software says, hey, draw a box around the field so that we know that we're in the right place. And it's looking for the issuer name. So that would be Mr. Green's Produce. And then the bill to address. And so that would be this Ann Arbor address. So you can very quickly rope over that information. And as soon as I accept that, you can see where it found the other pieces of information, but at a higher degree of accuracy. So we don't need to review that. I'm just going to hit submit. And now the software is going to send those 2 entries off for transcription. We also have 2 entries of transcription that need to be reviewed. So I'm going to perform those tasks. And so here you can see, written in cursive, kind of hard to see, Thomas Edison. And so we have a really intuitive interface. It's going to highlight the area that needs to be extracted, and then just give you an entry screen so that you can type it in and hit enter. That was the only one that needed to be reviewed for this document. If I hit enter again, it just takes me to the next field, first in, first out, document by document, based off of priority. And so here we can see some scratch out, and the software is saying, let's make sure we meet that output SLA. And I'm going to type that in, hit enter. And you can see now that we've processed all of the fields where the software raised its hand. Let's go back to the submission itself. So now we have some more information associated to the submission. We can see that of the 11 pages, 9 of them were pages that we cared about and extracted information from, and we had those 2 unmatched pages. If you'll remember, one of those was this sort of extraneous piece of information. So the software said, hey, not sure what this is, but I'm going to notify you in case this is important. And then we had that blank page. So we can either just drop that out or notify someone that one of those pages is blank. We can also see that we captured 304 fields off of those 9 different pages, and we're able to automate about 99.3% of the transcription if you could take into consideration the fields that we had to review and that we had to data enter. And then we can have that breakdown, of course, document by document. So 95% automation here, whereas on that second W9, we got 100% transcription automation. So let's take a look inside some of the fields, or inside some of the documents, and see how the software extracted that data. So I'm moving myself around again here. So right off the bat, you can see we start with Thomas Edison. And this was one of the two fields that an operator performed data entry on. And so you can always see that. So the software said, hey, this was transcribed by me. And you can see the raw information that, that the software captured. We also give every field a data type. And a data type is actually a machine learned data type. So we can certainly create custom data types. You can have regular expressions. You can have lists of values. But something unique to hyperscience is those data types actually become machine learned data types as well, to better understand, based off of the information that's being fed into the system, how to capture that specific field. If we move down here then to General Electric, you can see that it was transcribed by the machine and transcribed with a sufficient amount of confidence that the machine didn't feel like it needed to show it to an operator so that we could still meet that output SLA. And so here's the raw interpretation. And of course, we have a normalized interpretation. The software can also look at checkboxes and determine whether they're checked true or not checked false. We have an address data type. And this is actually an interesting field where traditional OCR would struggle not only with this unconstrained handprint. And what I mean by that is some traditional OCR tools have what's called ICR, that stands for Intelligent Character Recognition. But again, like OCR, tries to read things one character at a time. The hyperscience engine doesn't work in the same way. We actually use a lot of human intent and semantic information to teach our extraction engine how to transcribe things that don't necessarily work too well character by character. So for example, the still and the hill in Still Hill Street, a semantic understanding would understand that an I, an L, and an I probably doesn't make good semantic sense, or I, or LLL, where ILL in the still and the ILL in the hill would make more semantic sense. And so that becomes very confident to our application. Here we're just picking up another address. You can see here that there's a mixture. This is typed information, looks like maybe a stamp or a sticker. The software doesn't really care if it's typed or handwritten. It's the same engine that captures both. In this Parsippany, New Jersey, you can see that the box is where it's drawn, that some of the data goes below that. So as these P's, if we were to cut things off right there at the box, might look like D's, or this Y might look like a U, our software will actually follow the handprint so that it can understand, or it understands that the box itself is more of a suggestion. Sort of drive that point home, you can see here in the Social Security number, this is what we would call constrained handprint, but quite often people don't write as neatly as we would care for them to write. So in this case, you can see that not only were the numbers not necessarily put in the boxes very well, but sometimes they go outside of the boxes. In our case, the boxes are really more suggestions. The software is going to understand that the intent of the Social Security number, the data type, which was intended to capture 9 or 11 digits, might continue on. And so the software understands that and was able to very accurately extract the information. Same thing down here. They maybe started off well, but then they started mixing the data on top of the background and then not even putting it directly in the fields. But the software is able to drop out that background and understand the difference between what the form is and what the data should be. And then suddenly, whether they put it in individual boxes doesn't matter anymore. Here we're identifying that the document itself was signed. So we're saying it true that it was signed. And we always capture the X and Y coordinates of this information, of really any information that we capture, so that we can send this for downstream processing. We certainly have clients that are interested in the signature snippet itself so that they can use it for further line of business applications. And then of course, a date field where we can normalize the date based off of how it's written. So that's just a quick walkthrough of a structured document and some of the ways that we use artificial intelligence machine learning tools to very accurately and with high degrees of automation capture the data. Let's go look at a couple more. If we look at the other W9, we can really see how the pre-processing of the application understands how to capture data, even if it's in sort of a bad condition. So we capture this Christopher Thomas Knight, and we capture this Grossmont Corporation, even though there's some strikeout in here, right? So obviously whoever's writing this started writing something, wanted to scratch it out, and the software understood the intent of that scratch out, simply ignored it and captured the Grossmont Corporation in the background. And then of course we have the same addresses and zip codes and names, simply with a sort of a poor quality going on in the background there. Back to the submission. So this disaster loan application is a mixture of both handwriting and text print. When it comes to text print itself, the software does a phenomenal job. As you can imagine, capturing handprint is extremely difficult, but it actually makes the capture of text much easier. There's much less variation with text when you're looking at it from a semantics point of view. So text here, which is captured very well, and then we have handwritten data mixed in. And in this case, we actually have a mixture of handwritten and text data in the same field, and you can see that the software was able to very accurately capture that data as well. So far, we've just talked about capturing structured handwritten data, and generally you'll find that handwritten data is associated to structured forms, but we can also capture semi-structured forms. If we take a look at this waybill, for instance, you can see that we're capturing quite a bit of information here. So the shipper's name and the shipper's address, the consignee name and address, the voyage number, waybill number. And so this is, if you'll recall, was a PDF, and it had a text layer in the background. And then the software was able to use the information to go and find the specific blocks of data where we wanted to capture information, like a vessel name or the port of loading. So the semi-structured capture happens based off of a artificial intelligence or machine learned model, and the software is constantly learning as new information is presented to the model, and it rebuilds itself so that it becomes smarter and smarter as time goes by and as the application gets used, and more examples get sent to it for extraction. Same way for the invoice. If we recall here, this field was identified by me, but the machine was able to transcribe it very well. Same thing here. These were the two identifications we did. So just us drawing the boxes, but the machine, once we drew the box, was able to extract that information with high degrees of accuracy, as well as things like the bill to name, date, due date, terms, maybe total information. And then finally, the pay stub. And there's various pieces of information that we've configured the software to capture: the company's name and address, period ending, and pay dates. And it can even understand with the degrees of accuracy whether or not there's information that's present on the document. So in this case, it was very confident that we were not able to find a start date. Indeed, there's not a start date on the document. And then capture information. So this was inside of a gridded box. We were able to capture that very accurately. Year-to-date amounts, income tax, Social Security tax. So having looked at all that, once the software is done, it's ready to pass the information, the documents, the separation points, as well as the data that it extracted onto line of business applications for downstream processes. And so again, we have a variety of ways of doing that. We have integrations with common automation tools, as well as again, message queues where we can directly integrate and pass the information along. We also have a JSON representation. So through the REST API, all of the information available that we've captured, as well as snippets of the information and where the data is located page by page, the raw and the transcribed data, as well as who transcribed that data, whether it was machine or human. For ingestion, either for statistical analysis downstream, or simply to provide the information that a data entry operator would have traditionally needed to key into into the line of business application. Well, I hope you enjoyed that. Please feel free to drop by www.hyperscience.com. Thanks again.